Welcome to your mathematics class, student. I had started with probability in the last class. I defined what is conditional probability. Conditional probability of event E when event F is occurred is given by probability of E intersection F divided by probability of F. We defined this and started with properties of conditional probability. In properties of conditional probability, we have come to the second property where we prove this. Conditional probability of A union F when event F is occurred is given by probability of event A when event F is occurred plus conditional probability of event B when event F is occurred minus conditional probability of A intersection B when F is occurred, event F is occurred. This is one of the properties. Second property, what we stopped in the last class, we do this. In this, there is a condition that, in particular, if A and B are disjoint events. What are disjoint events? When A intersection B is equal to null zero. In such condition, then probability of A union B, conditional probability of A union B, when event F is occurred is given by only sum of two conditional probability, that is probability, conditional probability of A when event F is occurred plus conditional probability of E when event F is occurred. Let us see how to rearrange this. We had already proved the second property. Using that second property, we try to rearrange this condition. If A and B are disjoint events, if A and B are disjoint sets, we learn that in sets A intersection B is nothing but the null set. But here, even A and B are disjoint events, then what it proves? It proves that probability of A intersection B when event F is occurred, that is conditional probability of A intersection B when event F is occurred is equal to 0. If A and B are disjoint events, it implies conditional probability of A intersection B, since they are disjoint, when event F is occurred is equal to 0. If I substitute this in the equation, if I substitute this, I take it as equation 1 and this is equation 2. If I substitute equation 2, that is the condition, in equation 1, if I substitute that, I get back probability of conditional probability of A union B when event F is occurred is given by conditional probability of event A when F is occurred plus conditional probability of event B when F is occurred minus we get back C. So we can read it. So if A and B are disjoint event, conditional probability of A intersection B and when event F is occurred is 0. So if this becomes 0, then it is only sum of. This is a condition when A and B are disjoint events. One more property what we have, the third property or properties of conditional probability. Conditional probability of E dash when event F is occurred is equal to 1 minus probability, conditional probability of event E when F is occurred. E is the event, its complement is A dash. So we use this and try to rearrange. For this, I make use of the first properties what I learned. In one of the first properties what I learned, I had a conditional probability of event sample space F S when F is occurred is equal to 1. This was the first property what we do. Conditional probability of sample space S when event F is occurred is nothing but 1. Can I not write sample space S is equal to E union E dash? If I have an event, E union of its complement is nothing but the complete sample space. An event is given, you write the complement of that. The union of both of them, that is the elements in E and its complement, is nothing but the total sample space over time. So using that, I can replace S as the sample space as E union E dash when event F is occurred is equal to 1. In place of S, I will replace this because I know S is equal to E union E dash. Now, E and E dash, can I say they are disjoint? You don't have common elements at all whenever we consider set and its complement. So here I can say that E and E dash are disjoint events. E and E dash are disjoint events. If I get E and E dash as disjoint event, just in the previous property, we learned that probability of E intersection E dash under condition under the event F is occurred is nothing but 0. Just the previous one what we did, we learned that probability, conditional probability of E intersection E dash when event F is occurred is nothing but 0. We got that. So using that from the previous property, I write this as conditional probability of event E when F is occurred plus conditional probability of E dash. That is the complement of the event when F is occurred is equal to 1. So using the previous condition, since E and E dash are nothing but disjoint when I get the intersection of 0, I can replace this using the previous property. Conditional probability E union E dash when F is occurred is given by sum of two terms. That is conditional probability of E when F is occurred plus conditional probability of E dash when F is occurred is equal to 1. Using this idea, conditional probability of E dash when F is occurred is equal to 1. I shift this to R minus conditional probability of event E when F is occurred. Conditional probability of event E when F is occurred. That proves the result. So I just rearrange by shifting this to R. So this proves the result what is it. So these are the three properties of conditional probability. We learned three different properties. All the three proof we have proved. The three properties what we have proved in conditional probability. The first one, conditional probability of a sample space S when event F is occurred is equal to 1. Similarly, conditional probability of the same event F when event F is occurred is always 1. They are the same one, it is nothing but 1. Then, conditional probability of A union B when event F is occurred is given by conditional probability of the first event A when F is occurred plus conditional probability of the second event B when F is occurred minus conditional probability of A intersection B when F is occurred. We'll make a note in this case if A and B are disjoint. If these two are disjoint events, then this condition becomes 0. From that, we get back from the same property. Conditional probability of A union B when event F is occurred is equal to sum of two. Conditional probability of the first event A when F is occurred plus conditional probability of the second event B when F is occurred. Because we get back the intersection is nothing but 0. Conditional probability of A intersection F, sorry, A intersection B when F is occurred is nothing but 0. The third property, conditional probability of the complement E dash when F is occurred is equal to 1 minus conditional probability of the event E when F is occurred. So these are the three properties of conditional probability. We have proved all the three. Go through this practice. We will be using in the relevant problems where it is required. Now on conditional probability, we will work out few of the problems. One of the examples, while I explained about conditional probability, I gave you one example. Similarly, using the same definition, let us work out few. If probability of an event E is 0.6 and conditional probability, sorry, not conditional probability, probability of event F is 0.3 and probability of E intersection F is 0.2. Find conditional probability. The given probability of different events, event E, probability of F and probability of E intersection. They have asked you to find two conditional probability. Conditional probability of event E when F is occurred and conditional probability of event F when E is occurred. Let us try to solve this. We consider the first one. Conditional probability of event E when F is occurred is given by probability of E intersection. The definition says intersection of the two events divided by which event has occurred. Conditional probability of event E when F is occurred is given by probability of E intersection F divided by probability. We have been given the values of this. Let us substitute that. E intersection F is nothing but 0.2 divided by F is nothing but 0.2. Will I write it as 2 by 3 and considering the decimal places? Just replace the values from the data what is given. Probability of E intersection F is given as 0.2 and probability of F is 0.3. If I rearrange, if I cancel the decimal places, I get back 2 by 3. Then conditional probability of event F when E is unknown is given by probability of E intersection F divided by probability of E intersection F divided by which event has occurred, probability of, let me substitute, probability of E intersection F is 0.2 divided by probability of E is given as 0.6. Again, rearrange the decimal places, I get back 2 by 6. There are multiples, I can cancel, I get back 1 by 3. Given probability of two events E, F and its intersection, they are asked to find conditional. Use the definition of conditional probability and we have tried to rearrange this. Similarly, we consider one more problem. The next problem what we have is find conditional probability of A when event B is occurred if probability of B is equal to 0.5 and probability of A intersection B is 0.32. The second problem. The second problem, find conditional probability of A when event B is occurred is if they are given the two conditions. They have asked us to find the conditional probability with this table. Let us see how to find this conditional probability of event A when B is occurred. The formula is probability of A intersection B divided by which event has occurred? Event. Substitute the values. Probability of A intersection B is 0.3 divided by probability of B is 0.5. Now, I can divide this using the decimal places. I can continue. 5 6 are 30, 4 again 20, 5 4s are 20. So I rearrange it as 0.64. So 0.32 divided by 0.5. Rearrange by taking out the decimal place or directly divided you get back 0.6. That is the value what you get back for this conditional probability of A when event B is occurred. These type of problems will be asked you. So conditional probability, you can expect such problems for 1 mark in part A. Some of the times they'll ask you for 2 marks given 2 different conditions. So this is one of the important one where you can expect 1 mark or a 2 mark question on this, on such type of problems. Third problem, if probability of A is 0.8, probability of B is 0.5 and conditional probability of event B when event A is occurred, 0.4. Find probability of A intersection B, conditional probability of A when event B is occurred, and probability of A union B. Let us try to find each one of them. To find this, I make use of the condition or the formula of conditional probability of B when event A is occurred. I consider conditional probability of event B when A is occurred. Conditional probability of event B when A is occurred is given by the formula probability of A intersection B divided by which event is occurred? We already have the value of conditional probability of event B when A is occurred. So I use that formula where I get back probability of A intersection B divided by probability. Let me substitute the value. What is conditional probability of event B when A is occurred? It is given as point is equal to, I don't have the value of probability of A intersection B. So probability of A intersection B, I leave it as it is. I have to find out this alone. Divided by probability of A is given, which is nothing but point. Now, to find the value of this, can I cross multiply this? If I cross multiply 0.4 into 0.8 is equal to probability of A intersection and cross multiply 0.8 to the numerator. Now, 4 8s are, I can write it as 0.32. I have decimal place here and here, so 0.32 probability of A intersection. I have to find the value of probability of A intersection. The first one, we have got back as 0.2. So the first one we have got. Similarly, let us try to find the next one. So this is the first one, what we have rearranged. The same problem, we found probability of A intersection B as 0.32. Now, we'll go for the next one. Conditional probability of event A when B is occurred. What is it given by? Probability of A intersection B divided by which event is occurred? Conditional probability of event A when B is occurred is given by probability of A intersection B divided by probability. A intersection B when I take, I found the value. That was the first one, what was unknown. We completed that. So what is the value of that? 0.32 divided by probability of B is what? 0.1. If I divide this, I get back 0.56 are 30. 2 again is carried at the decimal place, so I consider 20. 5 4s are 20. 0.64. So conditional probability of event A when B is occurred is nothing but 0.6. That is the next value what we have. Let us find probability of A union B. We have learned the formula for this. What is probability of A union B? Probability of A plus probability of B minus probability of A intersection. Probability of A union B is given as probability of A plus probability of B minus probability of A intersection. Let me substitute the values. 0.8 plus 0.5 minus, what was A intersection? 0.32. Try to evaluate this. If I rearrange this, what do I get back? 0.8 plus 0.5, I will add up first. If I add up that, I get back 1.3 minus 0.2. If I add up 0.8 plus 0.5, I get back 1.3 minus. Now, if I rearrange this, 10 minus 2, that is 8. I would have carried 1, so 12 is left out. 12 minus 3, 0.98. 0.98. That is the value what you get back. 0.98. That is the value of probability of A union B. Let us consider the next one. Evaluate probability of A union B. If 2 times of probability of A is equal to probability of B is equal to 5 by 30. And the given conditional probability of A when event B is occurred is 2 by 5. They have asked us to find A union B probability. But for that, I just need probability of A, probability of B, and intersection. So first, I use conditional probability definition and try to find out probability of A intersection. So that is the same. I find that first and then try to deal. Now, conditional probability of event A when event B is occurred is already given. I'll use this condition to try to evaluate this. Now, what does the definition say? It says that probability of A intersection B divided by which event is occurred? Probability of A intersection B when event B is occurred. Let me substitute the value. What is the value of conditional probability of A when event B is occurred? 2 by 5. Unknown is probability of A intersection B. I don't have the value of this. I keep it as it is. I'm trying to find that. Divided by probability of B is given. 2 times of probability of A is equal to probability of B. That is what? 5 by 30. So I can say probability of B is 5 by 30. 5 by 30. Now, I'll try to cross multiply this. So 2 by 5 into 5 by 30. If I cross multiply that, I get back probability of A intersection. In the denominator, just 5 by 30. 5 by 30, I cross multiply. 2 by 5 into 5 by 30 is 5 and 5 get cancelled. 2 by 30 is equal to probability of A intersection B. I found the value of probability of A intersection. This was missing. I first found the probability of A intersection B, that is 2 by 30 to evaluate this. So first we have rearranged this value. Now using this we will try to find the value. So what was required was A intersection B probability. I had to use the other data to rearrange. Now I found the value, it is 2 by 30. Cancel 5 and 5, I got back 2 by 30. Now, using this, I will try to find the first one. What is asked to evaluate? What is asked to evaluate now? They have asked us to evaluate probability of A union B. What is the definition for this? Probability of A plus probability of B minus probability of A intersection. Using this, I'll try to find out the value of probability of A union B. Since probability of A union B requires an intersection, I found that first using conditional probability definition. Now I try to use probability of A. Given in the data, probability 2 times probability of A is 5 by 30. This is what I have. 2 times probability of A is 5 by 30. So if I want probability of A, 5 by 2 comes to the denominator. 2 into 30, that is nothing but 26. I have in the given data 2 times probability of A is 5 by 30. So that 2 I will bring to the denominator and rearrange. Now what does probability of A become? 5 by 26 plus probability of B, it is already given 5 by 30 minus probability of A intersection B is 2 by 30. So I have 5 by 26. I have rearranged that. Probability of B is given in the data 5 by 30. We found probability of A intersection B, that is 2 by 30. If I take the LCM, if I say 26 is the LCM, 13 and 26 are multiples. Now 5 It retains as it is 26 ones are 26, so 1 into 5 that is 5. 13 twos are 26, 2 fives are 10. Minus again 13 twos are 26, 2 twos are 5 plus 10, 15. 15 minus 4, 11 by 26. That is the value of probability of A union. Probability of A union B is nothing but 11 by 26. That was asked to find. We have found the value of that is nothing but 11 by 26. The problem was asked to find union. Since I did not have intersection, using conditional probability definition, I obtained intersection. Then I rearrange the value. The next problem, if probability of A is 6 by 11, probability of B is 5 by 11, probability of A union B is 7 by 11. Find probability of A intersection B, then two conditional probabilities. Let us first obtain probability of A intersection. With the given data, can I not use the formula of probability of A union B? I use the definition of probability of the formula of probability of A union. What is the probability of A union B? Probability of A plus probability of B minus probability of A intersection. Probability of A union B is probability of A plus probability of B minus probability of A intersection. Let me substitute the value. Probability of A union B is 7 by 11. Probability of A is 6 by 11 plus probability of B is 5 by 11 minus probability of A intersection B. Because this is the unknown. I don't have the value for it. I try to rearrange it. The remaining 3 is given. I substitute probability of A, probability of B and zoom. But intersection is unknown, I try to find. Since I have to find the value of this, I shift it to LHS. Since minus is there, when I shift it, it becomes positive. Probability of A intersection. I take back this to the end. And this, what I have on LHS, I shift it to RHS. What do I get? 6 by 11 plus 5 by 11. Since I shift this, it is positive. When I take it to RHS, it becomes negative. Now, I have somewhat difference of the fraction. I'll take the LCM as 11. All the three have the same denominator, so 6 plus 5 minus 7. If I subtract this, 6 minus 7 is minus 1. 5 minus 1 is 4 by 8. 6 plus 5 is 11. 11 minus 7, that is nothing but 4 by 8. So I got back the value of the first one. Probability of A intersection B I found. What is that value? 4 by 11. So the first unknown is okay. That is probability of A intersection B, which is 4 by 11. Similarly, I will try to find the other two conditional probabilities. Let me take conditional probability of event A when event B is up. Conditional probability of event A when event B is up. Probability of A intersection B divided by probability of A intersection B divided when which event is occurred? Probability. Let me substitute. Probability of A intersection B was unknown. We found the value of that. What is that? 4 by 11. That was not given. We tried to find that first using the formula of probability of A union B, and I got back 4 by 11. Divided by, I got back the value of probability of B. What is it? 5 by 11. The denominators are same. 11 and 11 I can cancel. 4 by 5 is the value of conditional probability of A when event B is up. Next one, conditional probability of B when event A is up. The next one, they reverse the events. Conditional probability of event B when event A is occurred is given by probability of A intersection B divided by probability of A. Probability of A intersection B divided by probability of A. Probability of A intersection B, we have found the value, I substitute that 4 by 11 divided by. Probability of A was also given in the data, it is 6 by 11. 11 and 11 I can cancel, 4 by 6, they are multiples of 2, so 2 by 3. So this is the value of the conditional probabilities of what is conditional probability of event A when B is occurred, 4 by 5. Conditional probability of event B when A is occurred is 2 by 3. So these are the few problems what we have worked out on conditional probability in today's class. In the next class, we will continue with few more problems on conditional probability. But these type of problems are important. Using conditional probability, given the condition, you may get 1 or 2 mark questions. So try to practice this. Whatever is done in the class or in the textbook exercise, try to work out the problems and practice this. In the next class, we will work out few more problems on this. Thank you, students.